Yes. Okay. Good morning, ladies and gentlemen. And now we will start diving into the world of PVsyst. Just to give you some ideas, uh, PVsyst, has any of you, maybe before I start, maybe let's make it a bit more, yeah, interactive session. Has any of you heard of PVsyst before? Or if not PVsyst, any other solar simulation tools?
Yeah, sure, we have heard about it. It is a famous program, and everyone here in Gaza, we design many projects on PVsyst. But just we want to follow up and get more information from you. So it is here a famous program in Gaza.
Very good. And why do you think we need to do why do we need to do simulations in the first place? What's the importance of doing simulations?
Simulation, I think you are doing it after you put all the inputs and then you get the results about the what input you have put. You will check the how much energy you have got and something like. Anyway, since 2 years, I did not even just click on this program before the war. So now I want to remember, but we designed one project on it.
Very good. Let's try all of us to remember, and just let's keep one thing in mind. PVsyst is really a very, I would say, big software. It can be sometimes you feel it's not very user friendly, but it's very important that you try to make the best out of it while you have the trial version. There is a very good help file with PVsyst. It's really very good. So if you have any questions, any issues, you can go to the help file, you can go to the online forum, and you can always reach out to me. Thank you, Muhammad. And you can always reach out to me if you have any questions. Now, PVsyst is really an old software. I think it's from the 90s. That was started initially in the university in Geneva, and then it became its own company, independent company. If we look at the top, this is the main screen when we open PVsyst. So we see at the top 3 types of projects that we can design.
Could you share the code? Excuse me.
Sorry. Yeah.
Could you share the screen with us?
It's shared. You cannot see the screen?
I can see it. So maybe
no,
it's on,
I don't see
on
it.
your side.
Okay.
I don't see it.
Maybe it's your connection then, I guess. It's maybe weak.
It is clear. It is clear. The screen is shared.
Maybe if Michael,
the screen is shared.
Michael takes off his video, maybe then the connection, the bandwidth is going to be better, and you might be able to see it.
There you go. I spared you from seeing my face. Okay. I don't know. Maybe you want to log in and log out and log in again, just to give it a try. Okay, let's continue now. So we have at the upper. This is the welcoming screen that we get in PVsyst. We see on the top the type of projects that we can work on and design using PVsyst. So we see grid connected, we see standalone in the middle, and there is pumping on the right side. Does anyone know the difference between these 3 categories of projects?
Yes, sure. We know about what is the difference between these systems. We know everyone is known. You see about the grid connected. This system. Hello, are you hearing me?
Yes, go ahead.
a grid connected system, this system is designed to be connected to the grid immediately and without any, backup batteries or any other, system like generator or anything. The
Yep.
standalone system, it is, the solar PV and with either with backup batteries or with the, generator connected or any power supply just to be connected as hybrid system.
Very
And
good.
pumping system, I think this system is used for pump inverter, where you want to just operate the pumps on the solar without any other power supply. That's
Correct. So why don't we add the pumping under standalone in this case? Because it's a standalone system. It's an off-grid system.
I think
why we added the
works
pumping.
without batteries. It
Yeah,
Exactly.
works without
instead,
batteries, directly from the sun.
Yeah, it is a
Exactly.
standalone without batteries. Actually, for the solar pumping, it is standalone without batteries. That is actually, it is being have a loan category in the BVSS, and I think it has good efficiency for simulation the solar irrigation pumping, the BVSS one.
Yep. That's very good. And if I remember, yes,
and
Muhammad.
also we can say that in a standalone system we have fixed frequency, but in pumping the frequency is varying from, for example, 30 to 60 according to the sun.
Very good. All of these are very good comments, and that and that's basically PVSys started initially as a tool for solar pumping, if I remember correctly, and then it expanded to take care of the rest. So with pumping, we don't have batteries. Now, today in our session today, we will start learning about grid-connected systems because it's the easier and it's a very good introduction into PVSys. So if you want to start designing a grid-connected project, we just click on it. And now we move to the main screen of grid-connected projects in PVSys. So let's look again at this window in front of us, and I will explain some of the what each part of it means. So the upper part, you see it says project. This project here, this part of the screen, it's about the main parameters of the project. The parameters that will not change throughout the project, because in PVSys you have project on the top and you have something down called variant. So basically the difference between them, all the parameters that are for the project will be fixed for all the variants. While down in the variants, you can change whatever you want and it will change only within that variant that you are thinking of. Think of variants more like scenarios. So basically, you make one project. Of course, for one project, you fix the site, you fix the name of the project, you fix the weather data for that project, and then you can do a number of scenarios. You can do hundreds of scenarios down. Each one of them, it's called variant. So whenever you change, that's why whenever you change one of the main parameters of the project on the top, you need to save the project again. So now in this case, let's give it a name, maybe a test, just whatever you want to call it. Yeah, and you will see in between these two areas of the screen, the area about the project and the area about the variant, you see an area where you get messages from PVSys. Now, these messages are helping us to try to understand what's happening and what needed to be done. So now we have a message in orange, which usually means you cannot proceed until you fix it. It says, please choose the geographical site. Geographical site is one of the main parameters of the project. So it will be on the top. That's why you see something that says site file under the project name. So we go here to the right side and we add a new site. Of course, if we want, there is a library of projects, library of sites in PVSys, but if you want to be more specific about your site, you just go and choose a new site. And here in the location, you can type on the top where is the location that you want to work with. So let's choose a place. You can zoom in
Sorry to
even.
interrupt. Would you maximize the PVSys window for the photo not to be distorted and more clear?
Usually it will not work very well, even if he maximizes it. You can try, Muhammad, to maximize the window, but usually it's
it can't be maximized. I tried sometimes, but it can't be maximized for the whole screen. No, it's the maximum size that we have.
So let's choose a location here on the map. You can even zoom further if you want to work on a specific roof or on a specific plot of land. We can do that as well. We choose it and then we click on that location. Yeah. And then you just click accept selected point once you are happy with your selection. Yes, Maria.
Just want to ask, is the satellite imagery up to date?
No.
How often is it being updated? Because yeah, it doesn't look very up to date, especially for Gaza. That changes a lot, right?
Yeah, I think they get it from Google. It was written there, so it all depends on how often they update that main source.
Yeah, Google imagery is very old. Normally, can be a few years old.
Yep, true. So now we clicked accept, and we see the screen asking us, giving us the main parameters of the site, which include latitude, longitude. It gave it a name. It's called Ganne Tal. I don't know what does that mean. If you want, you can change the name of it, the site. If it doesn't mean anything to you, so you can just change it. And it has also the altitude and the time zone. Once we are ready, we see on the right side that PVSys is asking us to import monthly weather data. Within the site, I know that usually a site is a geographical place. We don't think about weather data, but within the site, there is the monthly weather data in PVSys. So here it's giving us a number of data providers that we can use. Meteonorm is fine. Let's use it. Meteonorm 8.2. So you just click on import. And now for this specific site, this specific coordinates, PVSys is importing the monthly weather data. And now it's installed here for Khan Yunis. We see these are monthly values. That's why we have only one value for each month. We have global horizontal irradiation, horizontal diffused irradiation, and temperature. These first three columns are the minimum that PVSys would need to do to perform any simulation. The rest are useful, sometimes not, but these are the ones that you need indefinitely for every simulation. Now you click OK, and you will see that PVSys is asking you to save the site. It's good to save it in case you want to use it for a different project in the future. And now it's saved. That's what PVSys is telling you. And now let's read a bit this message here. PVSys is saying a synthetic hourly weather data file has also been generated. So if you remember, I was telling you in the site information, in the site data, we have monthly values, but PVSys would perform the simulations in hourly resolution. So what PVSys would do, it's going to generate something we call it synthetic hourly weather data. It's synthetic because it's not actual. It never happened in reality. This is just a year. It will convert the monthly values into hourly values. So once you said yes, once you click yes, you will save this hourly values into a Meteor file. Now, if you click save, it will be saved for the future. Now, you will see initially you started in the project filling the part called site, right? But with the site, we have filled as well the weather data file. You see at the weather data file, it says Khan Yunis, Meteonorm 8.2, and then it says at the end synthetic. Synthetic means this is not real values, because if you have real actual values, you can import it into PVSys. But now, so you know that this is synthetic.
I think it makes some, Michelle, I think it makes some type of interpolation between the data, the real data, between the monthly real data. That's it?
Yeah. Of course. It converts the monthly into hourly. So at the end, for example, when you take the average, the monthly average, it will be equal to the monthly values. It uses its own internal algorithm in this. Now, once we do any of these changes, once we do any changes in the 3 top lines, changing the project's name or site name or weather data, it means we have to do save of the project. So you just go up and click save. Now you see in the middle, PVSys is giving you a message in red. That's also not the best message usually. It means we cannot proceed until you do something about what we have written here. And here in this case, they wrote, please choose the plane orientation. So now we start working on the lower part of the screen. We are working on scenario 1 within our project that's called Muhammad in Khan Yunis. So the scenario 1, let's first start a bit brainstorming here quickly, all of us. And I really ask you to unmute yourself and just say the first word that comes to your mind. What do you think the parameters that we need for doing a solar simulation? Parameters means input. What are the input parameters that we need to perform a solar simulation? Can we start thinking about them a bit quickly?
Actually, you need the solar panel data, inverter data, orientations of the systems, and I think this information is the main information. Something else I don't remember.
That's true. Now, it's very good differentiation between main parameters that you cannot do the simulation without, and then, let's say, additional parameters that you can use to make your case more closer to reality or more closer to the actual case.
Yeah, but I think for the initial parameter that you have to think about is how much is the load. And if you don't know how much is the load, at least you know how much is the area that you are working on. That is exactly actually for the on-grid system that we are dealing with. And later, and sure that we fixed already the orientation, and we already mentioned Khan Yunis, so already we already fixed the orientation, so we know how much is the solar radiance and the insolation. So I think it is the load and it is the area at minimum. And later on, we can go for the other details like the data sheet of the PV and the inverter and the etc.
Now, we are working with on-grid systems. In on-grid systems, usually the load is not important. You add it, of course, you can add it down. You see there is something called self-consumption, and this is where you define the load. But when we're speaking about on-grid systems, the load is not among the main parameters. If it's an off-grid system, then definitely you need to define your load. But here, let's look at them, and we will start learning, at least from PVSys point of view, the main parameters. Yes, I see Auda.
I think one of the main parameters is the distance between my location and the nearest utility base station or transformer, etc.
Maybe. Let's see. Let's look into what PVSys is suggesting or what PVSys is considering main parameters. So let's start. If we look again, we see main parameters on the left side and optional on the right side. So under the main parameters, let's go to the orientation because PVSys is asking us, please choose the plane orientation. And plane here is referring to the modules. So we see here a number of options that we can select from. The first one here, it's saying field type. If you just click on it, Muhammad, just to see what are the options. So we have really a number of scenarios that we can choose. If it's a fixed tilt or if it's a dome, you know the dome is when it's east-west. I think Stan spoke about them yesterday. When we have seasonal tilt adjustment, I know many people in Gaza would maybe change, or at least in Syria they do that. They change the tilt of the panels between summer and winter to gain more energy. You can simulate the system. Let's start working now with the fixed tilt plane. Fixed tilt plane, it means it's a simple system that is fixed in one direction and one tilt angle. So here, let's remember one thing. When we are saying orientation in PVSys, it means the combination of both tilt and azimuth. So usually orientation, people think of it as the azimuth, which is...
Excuse me, please.
Yes.
I think there is a delay between your explanation or just clicking any button and when the screen is reaching to us. So you please, if you just after you change the screen, if you just wait for a few seconds and start explaining, because I told you there is a delay till
noted.
it reach the screen reach here.
Noted. So now here, I was just saying that in PVSys, an orientation means the combination of both tilt angle and azimuth. So if you have, let's say in your project, you have the same azimuth angle, but you have two tilt, you have panels are installed with two tilt angles, you need in that case to define two orientations. If you have the same tilt, but each of them is facing different direction, you have to define two orientations. So now, if we look at the parameters we see in front of us, we see PVSys is suggesting 20 degrees tilt angle and 0 degrees azimuth. What does 0 degrees azimuth mean?
It is how much you are far from the south.
So if it's directly to the south.
Yeah.
Correct. And now here, 20 degrees. Is that the optimum angle for Khan Yunis?
Actually, no.
I think in...
No, it is almost 30. Usually we use it 30.
Now,
30, 31.
Yeah, in Khan Yunis, in summer we use 50 and in winter 45. So the average we use for fixed system is 30.
Very good. Now let's see how do we figure out all of this just by looking here. Can you try to put here 20, Muhammad, please? Okay, now if we look on the a bit lower part of the screen, there are two charts, two curves showing here, two figures. One is showing you the tilt angle for the tilt, and one is showing the plane orientation. So if we look here, we see it says loss in relation with respect to optimum. It's written also on the left side. Yeah, if you just go to the left a bit, Muhammad. Yeah, or it's here, that's correct. It's minus 1%. So it means if I'm talking about the optimum angle, when I'm using 20 degrees, I'm 1% far from the optimum. So if you go to the tilt up and just change the tilt by clicking on the arrows, don't change it like this, change it slowly by clicking on the arrows, and let's wait a bit and see. See now, 21, it dropped to 0.8, 22, 0.6. I want this number to be 0, because if I have 0 here, it means I am equal to the optimum. Yeah, even if you take it a bit up, I think it will still be optimum. And you can always look at the number below. It says 2,163 kilowatt hours per meter square. That's the amount of radiation that will be hitting the panel if I put it with 29 degrees. See, even I think you mentioned 30 degrees. And if you put 30 degrees, I think it's also correct. Because, of course, here there are some numbers after the 0. So it's maybe 0.002, 0.003. So 30 degrees is correct. That's the optimum angle. If we are talking about optimization for an annual yield, you see down also in the middle, annual yield. It means if I use this angle, I'm going to get the best radiation throughout the year. If I want to use the summer angle, if I want to have the best generation during the summer, then what would be the angle? Yeah, you can click and let's try. Or maybe someone can give a guess, can try.
And summer 15 is the best.
Let's try and see. So you can change it now again, Muhammad, please. Here we are. At 15,
Yes.
we are at the optimum angle. We can try at winter. How much is it going to be, you think?
45.
And here we are, almost there, a bit more. Yeah, 40, 49 or 50. So here, this is how we define our project. Can you please return it to the optimum for annual, please, Muhammad? So this way, we can figure out what's the optimum angle. Please keep in your mind, this is according to clear sky model. What does that mean? This means, no, make it optimum for the annual. Yeah, exactly. This means that we are not looking into the clouds or the weather impact on the radiation. We are just considering that the sky is clear throughout the year. Of course, this is not correct because you have clouds, you have all types of things, but this is not evaluated here. We're just looking at a clear sky model. So now yes, Auda.
About the calculation of these values based on our selection for the geographical location and the data, scientific data which you have selected. That's true?
Yes. Of course. Now we are changing the parameters in the scenario, which means everything we chose for the project, will be applied for this scenario, for this variant. Now, we have selected that we want to use fixed tilt plane with a tilt angle of 30 degrees and azimuth angle of 0. So we are facing south. Can you just try to make it face east quickly? What's the angle? What's the azimuth of east? Maybe you have not spoken about that, but the azimuth to have the panel on the east is -90. Everything towards the east is minus, towards the west is positive. And if you look here now at the top view, you will see the panel is facing east. Do you see it? The red dot is from the top, so it's facing east. And if we put it facing east, you will see now that we are losing, how much we are losing because of this. Do you see it? 15.2%. So let's put it again at 0 and click OK. As you see here, we are at the maximum point. Now we see in the main parameters, the orientation parameter became green. You see the dot, how it changed from red to green. It means it's accepted by PVSys. And now PVSys is saying or writing there, please define the system. Yes, Abu Salim.
Hi, Michelle.
Hi.
There is some project. The use of the energy be maximum at a part of the same day. I mean, at the agriculture systems, the main use of the energy starting from the morning till the mid of the day. Is there at the PV system any categories that we can deal with the same day, not at the whole day, as you mentioned before?
In that case, if your load is, let's say, more sensitive towards the hours, and you want to see more generation during the morning, for example, then maybe it's better to try to work with an off-grid system, not an on-grid system, to be able to, I mean, you can still work with it here, but you will be able to see the impact more clearly in that way, to see how much is it better for you, for example, if you want to face east, if you want to make your panels face east, so you get almost as much as possible radiation during the morning rather than
yes,
in
that's
the
what I
afternoon.
mean.
Yeah, I
That's
understand your point.
I want if there is a simulation for the hours from 8 to 14 from the same day, and I wanted to direct the panels toward the east directly.
Yeah, I think it will be more visible if you go for an off-grid system and you define your loads in that case in the morning. It will be better this way.
Okay.
Yeah.
Thank you.
You're welcome. And now let's go to define the system. So it looks a bit complicated here, complicated screen. I will try to dissect it and divide it into small sections so you try to understand it better. First of all, the part in blue, you see there is part in blue, that's about the PV modules. Any information about the PV module you are using, you can find it here. The part in green is about the inverter. Any information about the inverter you are working with, you will find it here. The part below is about the strings and arrays. If you remember, we spoke about strings, which are a number of modules that are connected in series, and arrays, which are the total number of modules that you have at your project. It's about the configuration. We find all of this information here. Now, what's the best way to start here? We can start from the top if you want by something simple. But before that, I recommend always to start by choosing the type of modules you want to use and the type of inverters. So let's pick up one type of modules. Instead, not here. You need to click where it says generic. You can click there, and here you will find manufacturers of modules that are available now. You see on the top we have it's written available now. Let's go for any module. Do you know any module supplier? The famous ones.
Canadian.
Canadian, go ahead. I think it's CSI Solar. That's Canadian Solar. CSI, if you go down, down, up. Yeah, you see it? Yes. So this is, now we choose first of all the supplier, and then we choose the model, because of course every supplier, they have thousands of models. Let's choose a new model of modules. You can see when it's manufactured, which year, since which year. So let's choose something from 2024, 2025, whatever is available there. That's fine, any module, it's okay. Okay, we have chosen a module now, and we see this module is also bifacial. We can ignore it, just for us to know. Now, if we want to check the datasheet of this module, you click on Open. And here you will find all the information about this module. Short circuit current, maximum power point, open circuit voltage. You can even find on the top, you can click and see size and technology. See what's the size of this module. Up. It's 2.2 meters by 1 by 1. It's 32 kilograms. We see everything about it here. It's a bifacial module. It's anodized aluminum with aluminum frame. It has how many bypass diodes? It's written there. 3 bypass diodes. Half cut cell. We see all of this information here. Now, whenever we are checking the data sheet, I always recommend that you click cancel to go out of it, so we don't change anything and save it inside. Yeah.
But check, can it give you the option to change these parameters?
Of course.
But why to change it? It's like something fixed when you choose some models that is already manufactured.
Very
Why
good
it
question.
give you?
Why do you want to change it? Maybe you are working on a project that will be built in 5 years, and you think that the modules that are available in the market now will not be there, but will be better modules. So you can change it a bit to make a better module that will be available in the market after 5 years, for example. This is one of the reasons why you want to change it. Also, many times, you might not be able to find the exact module that you are working with. Maybe it's an old module. So the easiest way to do is to go and try to find a module from the same company, and then you change that module to the module that you have. And then you can save it. Okay, now let's click cancel. And now let's select the type of inverters. Do you know any inverters? If there are any inverters that you know that are available in Gaza, it will be good to use them. If you don't know, we can use, for example, SMA.
SMA, yes.
Yeah, SMA is down. Here is SMA. Let's go for the 20 kilowatt. It's one of my favorites. 20 or, yeah. You see the kilowatts are written on the left side, and they are ordered from the smallest to the biggest. Yes, let's go for one of the 20 kilowatts.
لأن عنده اتصالش هي اتصالش بتطول لما تصل عنا.
Okay, now we have chosen an inverter. I need you to click one thing there also, Muhammad, and I'll explain about it later. Under the inverter, it says PNOM sharing within the inverter. Can you click on that one? Okay. Now, we have selected the type of modules and we have selected the type of inverters. And now we are at almost half point in our session. There was another gentleman who also wanted to share his screen. Shall we try to use another screen and give Muhammad a break, or you are happy this way? If you don't mind, Muhammad, I prefer that you stay because now it's working well.
Can you hear me, Michelle? I lost your voice.
Yes, I can hear you.
Can you hear me?
Yes, I can hear you. Can you hear me? Can you hear me, guys?
Yes.
Yes, it's okay.
Yes, now. Yes.
Okay, very good. So let's proceed a bit with Muhammad. Now, we have defined the inverters and we have defined the modules. If we look down, we see that PVSys has already suggested a configuration. It's telling us immediately how many modules we can have per string. How many modules we can have per string? Can you see there?
10 models.
10 modules.
But what's the limit that PVSys is saying we can use?
18, between 10 to 18.
Okay. And how did we get this number? Do you remember?
Yeah. According to the VOC voltage of the panel and the VOC of the inverter.
And what's the maximum voltage? What's the input maximum voltage of this inverter?
800.
800 or 1000?
It's written from 345 to 800.
That's the operating voltage. But the maximum input voltage of the inverter, you see it's written down.
It's down.
It's 1000.
Yes.
And you see, PVSys has chosen a value for the lowest temperature that is accepted at site, that's estimated at site. And how much is this temperature? -10, correct. We see on the top on the panel or even down at the operating conditions that PVSys has calculated the open circuit voltage at -10 degrees. Because this absolute minimum temperature at the site is very important to calculate the maximum length of a string. You see on the top, it says 54.2. That's the VOC at -10 degrees. Yes. Also, you will see the minimum voltage of a string. That's important for a string, which is the VMPP at 60 degrees temperature. PVSys has chosen these two values, -10 and 60 degrees. Of course, we can change these numbers. Because, for example, in Khan Yunis, I don't think you will have -10 degrees, right?
Yes.
So
Yes, true.
let's try to change it just for fun. Now we have the value is between the numbers between 10 and 18. That's the strings that we are making. So let's click OK here. Just click OK on this page. Just click here. Yeah, let's leave it. Yes. And on the top, you will see something called project settings. On the right side, right. Project settings. Yes. Here, let's make the temperature, the minimum temperature, 5 degrees, for example. And increase the summer ambient temperature to 70. And now we click OK. Now we have changed a main parameter of the project. We need to save again before we proceed. You have to save your project again. And now we go to System again. And we see our range. Has our range changed or not? It's the same.
It's changed from 5 to 70.
Yes. And the number of modules that we can have in string, it's not anymore 10 to 18, it's 11 to 19. Because we have used higher temperature. Higher temperature means higher voltage or lower voltage?
Lower voltage.
Lower voltage.
Yeah.
And lower voltage means we have longer string.
Yeah.
So now we have our configuration ready. Now, if you have a range between 11 and 19, which one is better to work with, 11 or 19? And let's say you have a freedom to choose whatever you want.
15.
So you will go to the middle of the range. Why?
Because the optimum operating voltage for the inverter is from 345 to 800.
Yeah. But the operating voltage is related to the VMPP, not the VOC.
I think it is from 11 to 19. It is okay, but it is according to the system design, the needed number of models. We can choose the number, but it is okay.
Yes, but now let's say, Muhammad, if you have a very big site and you can choose whichever size you want, would you go for 11 or 19?
I will go for 19 to have a long time of operation.
I will go the same number with you, but for a different reason.
To minimize the current.
Minimize the current, minimize the number of strings, because, for example, if you have at your site, let's say you have 90 modules.
Yeah.
Now,
but I would like to ask, if I have, for example, 19, the system will start to be run, for example, at early time, because it will arrive to 345 voltage, the minimum VOC, the minimum needed voltage in the early time. Is it okay?
Now, between 11 and 19, they are all equal in terms of operation. If you go for 10, it will be outside the range. And I don't think, for example, the voltage does not change much with the radiation, if you remember. Not like the current.
Excuse me, actually you are doing this design for open area. Suppose you have a limited area on the rooftop.
Yes.
So it's not your choice to change the 19 on one string or something like that. You have to make it to be actually contained on that space. And mostly the design is happening like that.
Yes, that's why I'm speaking initially about when you have open. I want to understand how would you think when it's open, like if you are working on a large scale project.
Yes, okay. Okay.
Of course, if we're speaking about a limited space, that's a different story. If you cannot put, for example, 19, you will just go, if you have only 15, you just go for 15. At the end, 15 is within the range and it's accepted. Yes.
And even for, the open area, sometimes you are actually, you have to be, actually the area will control your design. Because you see, we have designed one 2 megawatt, solar systems. And actually it was not for us, just we are free to choose how many module in the string. It depends on the site, because the site is not regular distance. Sometimes it's going more narrow, sometimes it's more wide, and something like that.
Yes. Now, we as engineers, of course, we try as much as possible to control our project. If we cannot control it, sometimes we will have to compromise and live with what we have at the site. But let's say in the best case scenario where you can control things, this is what I would recommend to go for the biggest number, because in this way you would reduce your number of strings, and reducing the number of strings means reducing your cables, reducing your cable losses, reducing all types of extra additions that you have on the system. Now, we have done this. We have chosen, we can choose now our configuration. How to proceed from here? Now, there are two ways. For example, the first way is that we know how many kilowatts we want to install at this site. And the second way is that we know, for example, how many square meters we have at the site. So if we have 1,000 square meters available, how do we do it? We can go on the top and use something called pre-sizing help. In the pre-sizing help, I go to available area and I click here 10,000 square meters. And now you will see down, immediately PVSys has changed everything for me. It's telling me now I can fill in about 2.1 mega. Do you see it? It's written down. 2.1 mega. That's 3,888 modules. On the left side, I can see it. And these are connected in series, in strings, each one of them of 16, and I have 243 of them. And for all of this, I will need 84 inverters of the 20 kilowatt. You see, PVSys gave me all the configuration. I fixed for PVSys the modules, I fixed for PVSys the inverters, and then it recommended the whole thing. Now, if I want to go on the top and I say I want 200 kilowatt peak instead, I don't want 10,000 square meters. We will see again, PVSys recommended in this case to use 368 modules that are divided into how many strings do you know? Do you think? 23 strings. Each string, how many modules it has? 16 modules. And if I want to see how it looks like, on the left side, there is something called single line diagram. Click on it, please. Here we see how we are connecting our inverters. We have 7 inverters. Each of them is connected to three strings. And then for the last 2 strings, we will connect them to a separate inverter.
So far, the SLD not appeared here.
But are you working on your own computer or you're just looking at the screen?
It is the latency which Mr. Sheikh Ali said.
Yeah, but I thought it's just a matter of 2 seconds, but it seems to be more than that.
Of course, of course. Now it is appeared.
So you see, this is the configuration. This is how PVSys is designed, the SLD. Now, if you click close, are we back on the other screen? Can you see the other? Yes. Okay. Very good. Thank you, Manhal. Please keep me updated. Now, let's again look into this screen and try to remember some more stuff that we mentioned. So again, the blue part is about the PV module. The green part is about the inverters. And the part below with this gray brownish color is about the configuration. On the left side, you see something called Global System Summary. Here you can see the parameters of all the sub-arrays that you have. Because now we have only one sub-array in our system. I will not confuse you talking about sub-arrays, but there are a number of sub-arrays that you can increase the number of sub-arrays. Now let's click OK here. We have our system ready. Everything is fine. We can run our first simulation. You see what it says to you in green? Ready for simulation. So you just click Run Simulation. Now these are here the results of the first simulation that we have done. Can you see what's the energy production out of this system? Can anyone tell me? No.
System.
Could you repeat the
Actually,
question?
system 366 system production.
Correct. So our system has a production of 366 megawatt hours. The number under that number is called specific production. Does anyone know what specific production means? If you don't know what it means, just look at the unit.
It is after the ratio or after the performance ratio or after the losses, you can say like this.
Both of them, system production and specific production, are after all the losses.
Yeah, but this is actually the specific production. It is giving for the kilowatt peak. How many kilowatt
Yes,
hours is
it is
giving?
kilowatt peak. Yeah, it is almost for 1 year, but for each kilowatt peak. And for the one, the first one is a sum of a production over the year.
It's
for all
the
of the
first
system.
one for all the system. That's correct. All the
Actually,
kilowatt peak.
Actually, here in Gaza, we are considering that 1 kilowatt peak daily is giving about 5.2 or 4.8 up to 5.2 kilowatt hour. So this is the specific it is giving for 1 year. But actually, we consider sometimes multiplying by 360.
Yeah.
So the
And
daily.
if you divide this number, you should get the daily.
Yes. Yeah.
So if you try to divide it for us, please, Muhammad. Yeah.
For this number, actually, we use it earlier as a guarantee from some companies when actually installing on a grid system. But actually the threshold was lesser than this. It is almost 1,700. And that's actually depends on the technology that we are using. Each time we have better technology, we got higher threshold.
Yes, and also let's keep in mind here that this number is now really on the upper side. There are many losses that are not taken into consideration, which we will be adding them now shortly. So, but it's very important that you, ladies and gentlemen, understand what specific production means. It's a very important tool for comparing the different scenarios that you are working with. Because this way, if let's say one scenario is giving you 1825, another scenario is giving you 1500, and you want to compare which is better, then you know the specific production is a very good number to know which system is the best design that you have. Under that, you have something called performance ratio. It's an important number, but I think it will take a lot of time to explain it. So maybe we will skip it for now. Now, if we want to look into the losses that we are working with, and here, from my point of view, one of the most important things you get in PVSys is the loss diagram. Can you click on the loss diagram, Muhammad? Please let me know when you can see the loss diagram screen.
Yes, we can see it.
Okay. Now, this loss diagram screen is really the single most important thing you can do or you can look at in PVSys, at least in my point of view. Especially in your roles, because many times the contractor will come to you and bring for you a simulation. And the fastest way to see if there is anything wrong is to look at this diagram and see what's happening there. You will see this diagram is divided into two parts. They are not equal. The upper part is the optical losses or losses in the radiation. The lower part is losses and gains in electricity. So on the top, always you will see the unit kilowatt hours per square meter because we are speaking about radiation. While down, we are already electricity because this radiation has entered into the modules and it's converted into electricity using the efficiency of the modules. You see, that's why they keep for you efficiency at STC in between these two parts of the diagram. Because this is how we convert the upper part into the second. Obviously, the number we start with is what we call global horizontal irradiation. And that's the total amount of radiation that's hitting a horizontal surface at Khan Yunis. And then, of course, when we are saying losses, it means there is losses and gains. They always appear here together. So the first number is a gain or a loss. What do you think?
It appears
Again.
as a gain.
Again.
It's a gain.
Gain. Okay.
And why we have a gain here?
Because of the bifacial.
Not the bifacial. If we want to understand something, let's read what's written next to it. It says the first number on the top is global horizontal irradiation.
Maybe because of the temperature.
The second one is
No,
global.
no, it is because of the tilt angle.
Correct. Correct. Because when we tilt the panel, we gain more radiation, right? That's why we tilt the panels, to have more radiation than horizontal radiation, because the radiation is more perpendicular to the panels. So when we tilted our panels by 30 degrees, we gained 10%. But then after that, we have lost about 1.7%. This is called incidence angle modifier. To make it simple, these are reflection losses. Think about it this way. Not all the radiation that's hitting the glass of the module is going inside. Some of it is reflecting, right? Like any glass in the world. If there is some radiation hitting it, some of it will be reflecting. So in our project, we are losing 1.7% of the radiation because of this. In our part of the world, what would be the biggest type of loss?
Usually temperature have higher loss.
And if you look in front of you, which one you see there?
It's temperature, surely.
How much we are losing because of the temperature?
I think almost 9%.
Correct. We are losing 8.6%. So what PVSys does here, you see array nominal energy, and then at standard test conditions. At standard test conditions, what was the temperature of the modules?
25 degrees.
25 degrees. Now, each time the temperature is above 25, we are losing. So here PVSys is taking what would be the temperature of the modules in real life and seeing and checking what will be the amount of the loss in the temperature. And the value here is 8.6. How much we are losing because of converting the electricity from DC to AC? Maybe I should give you some more information first. The lower part of the loss diagram is about losses electricity in the system. The upper part of it, the upper part of the lower part, I mean, is losses first in the modules, and then losses in the inverters. You see the bold line? The first bold line on the right side is the array nominal energy. These, and under it are the losses in the DC side. Then the second bold line is array virtual energy at MPP. All the losses after it are losses in inverters. And then you have losses in the system. We don't have any of them here, but we will talk about them. So the first one is the loss, the efficiency loss of the inverter. We are losing 2%. The second one is inverter loss over nominal inverter power. That one deserves that we talk about it separately. So let's close this loss diagram and go back to the system. Also, let's close this after we save it. You want to save it? Yes, let's save it. And let's go to system again. Okay, everyone, can you see the screen of the system?
Yes. Yes.
Okay, now in the system, do you remember what will happen if we exceed 1000 volts for this inverter? This inverter has a maximum voltage of 1000 volt. Is this correct? What will happen if I connect to it 1100 volts?
It will have some sort of
Maybe-
re-rating.
Yeah, maybe it burn.
Do you think
Actually,
the inverter?
it will affect the efficiency of the inverter. Definitely, temperature always affecting the efficiency of the inverter or the equipment.
Try to put 20 modules. If you put 20 modules, basically, it means you are exceeding the inverter limit. Yeah, put here 20 modules. You see what PVSys is saying? The voltage is higher than 1000 volts. To be exact, it's 1043 volts. Do you see it in green? In the middle. Down a bit. Just, you see there is a small square called operating conditions. You see, VOC at 5 degrees is 1043 volts. Now, why PVSys is not accepting that I proceed from here if it's about derating? Because if I exceed the maximum acceptable voltage of the inverter, I will burn the inverter. That's
But
why
actually,
PVSys...
actually there will be some percentage to exceed this one. I don't think if we exceed it with the small amount of volts that we will go for burning immediately, because sometimes if for short time you exceed it due to I don't know some system problem, I don't think you will burn the inverter, but for a long time that's happening.
You will burn it. That's why your role as an engineer is to try to make sure not to exceed this. You will damage it. If you will not burn the whole inverter, you will damage it.
Sure, for the design you have to consider that, but I mean, if temporarily it has gone up, it will not burn the inverter.
It will damage it. I assure you that.
Maybe.
So let's return it back to 19. So now, voltage is very important that we don't exceed the voltage of the inverter. But how about the current of the inverter? Or how about the power of the inverter? Can we exceed the power of the inverter?
Yes.
Yes.
Have we exceeded here the power of the inverter in our case?
Yes, we exceeded.
How much? By how much?
I think we have a percentage until 25%. We can increase, and in some cases, actually, in Australia, they make it until 1.5. But for our circumstances here in Gaza, we use it 1.25. I think it can do well.
Let's look a
Actually,
bit to the left side.
it depends on the manufacturer, how much the manufacturer will say that that percentage is not for all the inverter same. It's 1.2 sometimes, and sometimes they ask you to load it up to 1.1. It will be in safe, side.
You will
So
be
it
able
depends on the
now with
inverter itself.
using PVsyst, you will be able to judge how much you can oversize it. Now here on the left side, what's the size of our system on the DC side? What's the size of the solar part of the system? When we are speaking about the DC side, we always use the unit kilowatt peak. So here the nominal PV power is 238 kilowatt peak. And what's the size of the inverters of our system? It's 160 kilowatt AC. So we have exceeded 160 kilowatt AC, right? What's the ratio between the two? This is the DC AC ratio. We are using now 1.5. Can I use 1.5? Well, I can, as we see here, but what do I have to pay when I use this 1.5? Or what am I losing? I want you to quickly, for me, Muhammad, open the data sheet of the module on the top. Yep. And let's go to graphs. Up, 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 up. There are commercial graphs, additional data. And I want you to show me here the power versus voltage on the left side. Okay, can you all see the graphs?
Yes.
Okay. So you see these are the IV curve. This is the power curve. And you see the maximum power point, right? It's at the top because this is the power curve. My inverter, it's an MPP tracker inverter. This means it will try all the time to find the maximum power point, right? But what happens when I'm exceeding the power of my inverter?
I will take less power at maximum power point.
Exactly. So the inverter will move the operational point from a maximum power point to another point, to the right or to the left. But what does that mean? It means instead of generating 508 watts, I will be generating maybe 490, right?
Less than that number.
Yes. So it means I am losing energy, right?
Sure.
Yeah, right.
So if you close this one here, how much energy I'm losing? If you close this one again by clicking cancel, in this case, you will see my overloading losses are equal to 5.1. Do you see it? In the part of the screen where we talk about the configuration. It's written in orange. It says overload loss 5.1 on the left side, next to the sizing button. Now, how do I fix this number? How do I make it less?
You reduce actually the overloading You might use 1.25.
How do I do that?
While actually reducing the capacity of the PV system or the PV panels.
That we can do. I can also reduce the number of modules in series, right? Or
Yes.
if you don't want to change anything, let's add an extra inverter. But here you go, Muhammad fixed it. So now,
So you might, yeah.
So now we have fixed it. We have dropped the value to 1.25 by reducing the number of modules in a string. And now how much I'm losing?
It's almost nothing, 0.5%,
0.5.
and you already added 25% for the overall system.
If let's return it again as it was 19, I think, before, or yeah. And now we will see again we are at 5.1. Go on the top and just add one more inverter. It will do maybe the same job. Add a second one maybe. Yeah. Now we're fine. It still has a comment on the right side, but that's more on practicalities, because you have 23 strings and it will be difficult to divide them into 10 inverters. Which is fine. That's something.
Okay, Michelle, I think you do have some scenarios, different scenarios in order to reduce the losses, the overload losses. But does PVSys, this program, give you points of economical issues and the cost, that if you have two options here in order to increase this or decrease this?
Yeah.
So can PVSys offer you the best cost or the best economical point that you can get?
Usually, you don't have two choices, because usually if we look at the real case, you have an area on the roof, and usually you want to maximize the number of modules on that area. So usually you don't want to reduce the number of modules to save this case. So in reality, probably the best is to increase an inverter, because you want to maximize your number of modules. But if I go back to your question,
but in our case, we did reduce the number of modules.
Yeah.
So the restrictions of the space is not found. So it's better for me just to reduce the number of modules.
Yeah, you mean in your case in our project here, or
yes.
We can do either way. PVSys does not provide. I mean, there is commercial simulation in PVSys, but no one uses it because everyone wants to use their own Excel sheet.
I see. Okay,
the last thing you want is to use. I never seen anyone using it, honestly, because no one trusts anything except for their own Excel sheets.
Yes.
But basically, let's go back to one question here. Why do we oversize the DC side of the system? Why do we go for 1.25, not for 1? Why don't we use 1?
Actually, sometimes they are doing it because they want to increase the production on the time where the radiation is not going to maximum. Sometimes from the morning or from the evening or during the winter. So they increase the number of modules. Something like that, there is a thinking.
No, but why do we use this DC-AC ratio more than 1? Why don't we use 1?
Because it sometimes be different from the standard testing condition, the 25, sometimes in the morning.
Exactly.
It's maybe less than 25, and after noon, it's less than 25 or something like that. So the differentiation between the STC point and before and after.
That's something you always need to keep in your mind. When our system is 10 kilowatts, it doesn't mean it's going to generate 10 kilowatts. You will never see it generating 10 kilowatts.
Yes.
Ever. Because the standard test conditions, they will never happen in real life. When the radiation when the radiation is high, the temperature will be high. So if I have a 100 kilowatt system, and it will never generate 100 kilowatt, maybe the maximum it will generate is 80 kilowatts. So why should I buy inverters for 100? Then I can be fine with inverters for 80. And that's what we do in this case. In that case, it will be 100 divided by 80. That will be 1.2 DC-AC ratio. So that's why in the first place, we use bigger DC system than the AC, or that's why we use smaller AC system than DC. Okay. I think now we are done with the time. I mean, PVSys is definitely a full world, and there is a lot that you can do there, a lot. And my intention was just to try to give you the keys, how to enter this world of PVSys. I hope I managed to do that. If you feel you would like to do more of it, I think maybe just let's give the feedback about that. Just share your feedback. I don't know I think it's Hiba from your side, Engineer Hiba, who's in charge of the training. And we see, but that's what I really wanted to share with you today, because I know the time is limited and we cannot do everything. I hope you feel this was useful, and more importantly, it will help you that you start working more on PVSys and try to discover more about it yourself. Yes, Abu Salim.
Yes. You didn't mention how we can the whole system perform on the ground. The PV system give me the area wanted just like a number, 1123 meters square. What is the adjacent space between the strings we need?
Yeah, I mean, that will take another 3 hours. If you feel we need more of this, you would like to know more about that, I think we can discuss. Just tell us what do you think about it, and we can discuss it.
Give me a help where I can start from the PVSys.
Yeah, I can give you some help. We can take 5 minutes for that quickly. If you close here, yeah, click close. And if you go to near shading, so now in the near shading, we go to something called construction perspective. And here, basically, we move from only tables about our system into a 3D, and we work with the 3D. Yes, we can do 3Ds in PVSys. So for example, here, if you click create, you can either, let's say, add a building. So you add elementary shading object. And here, if you go to shape type, and go to house plus two-sided roof, for example. Yeah, and you click OK. So you can create 3Ds in PVSys and add the solar panels on the rooftops. Or you can even create 3Ds in another software and import them in PVSys and add the PV modules on the rooftops. Or even you can just, if you're working on a ground system, you can just import the ground here. So if you, for example, click on create, no, sorry, at file. Yeah. And go to something called import. And then go to download a satellite ground image. And then you can zoom in here and choose which area you want to import into PVSys. So if you have a plot of land, you can import it into PVSys. You can zoom in. Yeah. And then you just click OK. And if you click on the top view, you can click it up. It says point of view, the ones in blue. Yeah, top view. So you see here, now you have the land and you can move your house and put it wherever you want or install PV modules there. Okay, this is just how it starts. Of course, it's not very straightforward, but the new versions of PVSys are a lot easier to work with than before. It used to be so complicated. Okay, thank you guys. I really suggest that you play around and try to discover more with PVSys, and I'm ready to help.
And Hiba, as Michelle suggested, if there is feedback on follow-up session specific topics, that would be useful. If you can collect feedback, that would be great.
Good. Thank you, ladies and gentlemen. It was a pleasure. شكرا.
Thank you. شكرا.
أهلا وسهلا.
Thank you. Thanks a lot, Michelle.
Thank you. Bye.
Bye bye.
Okay. Goodbye all.